class we are going to discuss about the transfer function. Transfer function is nothing but the relationship between the output with respect to the input. So if we have a control system and we have an input which is denoted as R of S and we have an output which will be denoted as C of S. So C of S, S stands for your frequency domain. For example, we can take R of T, C of T, which stands for your time domain. So S stands for your frequency domain and T stands for time domain. So for a control system, the transfer function can be given as C of S divided by R of S. So relationship of the output with respect to your input. So now we are going to construct a mathematical modeling of an electrical system and we are going to derive the transfer function. So mathematical modeling of an electrical system, let us consider an electrical system which has a transistor R and an inductor L and which has the input of V. So we know R and L. R is your passive component and L is your active component. And now let us write a mathematical equation. So we know if we have voltage supply as an input, definitely there will be a current flow in my circuit. So here output will be my current supply and input will be my voltage, right? So whenever we have an voltage supply, we know there will be a current supply through one circuit and there will be a voltage drop across the components. So now we can take V of T, that is input is equal to the voltage drop across the resistor. What is the voltage drop across the resistor? According to Ohm's law, V is equal to IR. R into I plus L. Across the inductor, the current will be varying with respect to time. Since starting point, the inductor will be 0. The current through the inductor will be 0. But for the time being, there will be a small amount of current stored in my inductor. So the current through the inductor will be varying with respect to time. So we are writing di by dt. We know this is the mathematical equation of this particular circuit, right? Now I have to find out my transfer function. So whenever I have a circuit, first step is to find out the input and output. First step is to find out input and output. Yes, I have found out my input and output. Second step is to find out the mathematical equation. So I have written my mathematical equation and third step is to apply Laplace transform. So why I have to apply Laplace transform? Any idea? Why am I applying Laplace transform? Because I have to convert this to a frequency domain. And so I am applying for the Laplace transform. So V of S is equal to R into I of S plus L into S I of S minus I of S. Why I am taking S into I of S and minus I into I of S? Any idea? Because I have d by dt. I have a time varying constant here. So for the d by dt, I am representing it as S. If I have the dA, I will be writing as S into A of S. So whatever the term may be, if I have d by dt, some variable with respect to time, varying with respect to time, I will represent it as S. So I am taking two conditions, that this is varying with respect to time and this is the initial condition. For the initial condition, I can represent as I0. So we know at initial condition, I of S will be 0 in my inductor, right? Before starting the circuit, we have no current supply into it. So automatically no current will be stored in my inductor. So I am neglecting this term. So I can rewrite as V of S is equal to R into I of S plus L into S into I of S. So what I have to get my transfer function. Transfer function is nothing but output by input. Here the output is I of S, right? So what I am doing, I am taking I of S as common. I of S into V of S. So now I am rewriting what will be the transfer function? Output by input. I of s divided by V of s. We can rewrite it as 1 by R plus Ls. So I am taking this numerator down here. I am taking this numerator down here. So finally, my transfer function for this particular electrical circuit is 1 by R plus Ls. So any doubt in this circuit, or what about the transfer function? In the next class, we will be discussing about the mathematical modeling of a mechanical and rotational system.